Hello, and welcome to the OI Connector installation demo. The goal of this video is to introduce, install, and demonstrate the OI Connector, which facilitates integration and data flow between DX NetOps and DXOI. Through this integration, the business value to be gained by OI operators is their ability to more completely, more holistically represent and monitor those business services that support their stakeholders. And the key in doing that is really to ensure that all monitored underlying entities that support those services are appropriately represented within OI. Because ultimately and ideally, OI services should be modeled to be inclusive of all of those critical resources that participate in delivering applications or services within an organization. In the NetOps case, the OI connector enables OI service definitions to include network entities, which are almost always foundational to applications or service health. So the integration allows NetOps metrics, inventory, and topology data to flow into OI. And in the end, it enables service owners to better understand how network service quality metrics are contributing to the overall health and performance of their key critical business services. So before jumping into the installation, let's take a little bit of time to review the overall architecture and data flow. So what are the resources we can expect to receive from NetOps within OI? Well, primarily they are NetOps inventory and topology, which is basically all devices across tenants within NetOps portal, and also metrics. So by default, the OI connector will receive the following metric families out of the box, and they are availability, reachability, port, CPU, and memory. And these metric families and metrics are customizable within the connector configuration. When we look at this architecture diagram here, the light blue components represent NetOps, the light green represent the OI connector, and the pink is the OI platform data stores. So the OI connector service here is really the core central service of the OI connector. It's responsible for sending both inventory and metric data to the OI data stores. The metric data is stored in NAS, while inventory and topology data is stored in TAS. So how does it actually collect this data from performance management? Well, the inventory data is pulled from NetOps portal by the OI connector. The connector will create a group within NetOps portal that contains those devices that will be sent to OI. And that group is called the OI inventory group. It contains a reference to the OI seed group. Now on the metric side, within PM, the data aggregator component contains a metric publisher, which is essentially what it does is enables forking of metrics onto a data bus at the same time they are loaded into the PM database. And additionally, the metric publisher has a subscription REST API. And this is what allows clients like our OI connector to specify the inventory, the metric families, and the metrics that should be published onto the bus. The connector does this by creating an exported metric configuration within PM's consolidated monitoring profile. So the connector is essentially telling the data aggregator what metrics it wants sent to OI. And after the OI connector core service makes that subscription to the metric publisher, it will then subscribe to listen on that Kafka topic for PM metrics. So it listens on the bus for PM metrics, and when it receives those, it processes them and sends them to NAS via the NAS client. And down here, the OI connector agent service is a subservice of the OI connector. So this subservice is responsible for querying and sending DX NetOps network flow analysis, NFA, and CA application delivery analysis, ADA, those product metrics to DXOI using the inventory scope that it receives from the OI connector. So now that we understand the architecture and the basics of the data flow, let's talk a bit about the prereqs of the installation. And I wanted to bring this up just to touch on the compatibility matrix. So the latest version of the OI connector at this point in time is 2.1.1, and that supports OI 20.2 or higher, NetOps PM 20.2.4 or higher, and NFA 10.0.4 or higher. This latest version of the OI connector introduces some pretty significant underlying changes with regard to the introduction of the Kafka data bus as a means of more effective and more performant metric publishing. So that really kind of forces the need to be up on these later versions of these products. At the same time, the previous version of the OI connector, 1.5, does support the versions that you see here as well. In addition to the compatibility matrix, looking at the OI connector system requirements, the connector itself is recommended to be installed on a dedicated host. Any Linux kernel platform will do, and just some guidance around memory, CPU, and disk. So the memory is really governed by the amount of devices or pulled items from NetOps portal. So you'd want to review this and kind of map to memory as needed. Processor, 8-core, and then disk, 60 gigs if you're installing a local single node Kafka broker on the connector itself. So that Kafka broker is included within the connector, so it will install the Kafka broker. But you also have the option of specifying and utilizing an existing Kafka cluster broker. If you do have it already installed and configured, you use it, and you would like to use it for the connector, you can choose to do that, and you can specify it during the installation, and it will reduce the amount of disk space required by the connector if that's something you want to do. Continuing with the prereqs, there are several parameters that need to be provided during the connector installation that are specific to individual OI and NetOps PM environments. Number one is your OI tenant or cohort ID, which is the unique identifier of the OI tenant you are integrating via the OI connector. Number two is the OI gateway hostname, which is the URL that enables the connector to communicate with backend OI data stores, like NAS and TAS, in order to store the NetOps data. Number three is the gateway token, which provides security authentication against the aforementioned gateway. And finally, number four, in order to connect to the NetOps portal, a user account must be provided and used. It's recommended that a dedicated user account be created for the purposes of OI connector. And it's recommended that this also be a non-expiring password to avoid any interruptions, disruptions related to password expirations. In the latest version of OI, the first three parameters listed here can be easily obtained by actually clicking on Settings within OI, and then the recently added Connector Parameters tile. From here, you can copy the cohort or tenant ID. You can copy the TAS-NAS endpoint parameter, which contains the value to be provided as the OI gateway hostname. And finally, you can generate a token that enables the connector's authentication against OI. So it's recommended that you have this page available open during the connector installation, or you can copy these parameter values somewhere safe so you have them handy when going through the actual connector install. And finally, just wanted to highlight and share some information for awareness when it comes to the component ports. Just to have that in mind in case there are firewalls between NetOps and the connector or the connector and OI. So these are ports, Kafka ports, the NetOps portal port, OI port, and these are available for review within the documentation as well. So I think we're good, and let's actually begin the connector install and start with the download. So the connector can be installed from the support.broadcom.com site. Once logged in here, if we go to Enterprise Software, and then product downloads. And here I'll search for performance management. And then DX NetOps multi-platform as the product. And I'll just do a quick search here for connector. And here's my OI connector for NetOps. And from here I can just click on download HTTP via internet browser, and it will kick off my download. Okay, so we've downloaded the connector binary. I've actually FTP'd it over to my Linux host that will be running the connector. And let's go into the directory. Here I have my binary. It's the one that starts with GEN. I'm just going to issue this command here to make sure I have executable permissions against this file. And looks like I'm good to go. So I'm going to kick off the install. Okay. We'll go through the license agreement. And then click, and then type a Y for yes. It'll offer the option of having the connector install put down a JVM, or you can choose to use your own if there is one on the system. In this case, I'll have the installer provide one. And here's where I can select my installation folder. By default, it will install to opt.ca, and then it will create a subdirectory called OI connector. And I'll take the default here as well. Okay, OI connector to NetOps portal configuration. So here's where we provide the parameters that enable a connection to the NetOps portal. The protocol, my NetOps portal is HTTP. The host name, I'll provide my NetOps portal host name here. It will ask for the port. 8181 is the default, and that's mine. Tenant, you can specify a particular tenant. If you take the default, that will be inclusive of all tenants. And this is something that can be modifiable after installation. It's a configurable parameter within the connector itself, so we can always change that. Username, admin is the one that I will use. And here I will provide the password for the admin account. Okay, so link back to NetOps portal configuration. So here is where we have the opportunity to provide a proxy in case it's not publicly accessible, that URL that we see here. In this case, I don't require any kind of proxy or public route, so I'll say no. And now OI gateway connection. So here is where I specify the information and the parameters that we talked about earlier that we got from that connector parameters page within OI. And this is basically enabling a connection to the OI gateway and the backend services like TAS and NAS. So in my case, protocol is HTTPS. My host name is APM GW. And the protocol for me, I use HTTPS, so it's going to be 443 as the port. Okay, my tenant ID, I'll provide that here. My security token. Okay, and the OI connector agent. So enter the port for OI connector agent service. This is the port that the OI connector core service uses to communicate with the OI connector agent subservice. Just take the default here, and the OI connector status web service port. This is the port that NetOps portal uses to check on the health of the OI connector, and I'll take the default here. Okay, metric data bus. So here is where you can specify whether you would like the connector itself to install Kafka messaging bus, or you can specify your own existing Kafka bus if you have one already installed externally to the system and perhaps installed in a HA configuration, or if you have a certain way that you like to manage Kafka, you can certainly specify that external Kafka. In this case, I'll have the connector install its own. Okay, and again, asking for HTTP proxy. In this case, I don't have one. I don't require one, so I'll click no. And here's where it's asking for the Nfa agent configuration. So if I have Nfa agents out there that I want to pull metrics from, I can configure that here as well. In this case, this demo is focused mainly on performance management integration with the connector, so I'll click no here. Okay, and that's it. So here's my pre-installation summary. I can review everything here, and it all looks good. I'll click enter, and it will initiate the installation. Okay, installation completed successfully. I'll click on enter and exit the install. There is one post-install task that needs to be completed within NetOps in order for the metric data to begin streaming into OI, and that is to update the data aggregator metric publisher with the Kafka Broker that we've specified as part of the connector installation. So we're basically telling the metric publisher where to send or stream the metric data, and that will be to our Kafka Broker. So let me open up my file that I've updated, and we'll take a quick look. Okay, so I'm here on the data aggregator server in the home directory. We'll take a quick look here. We're going to cd into Apache and then etc. And we are looking for the Kafka export.producer.config. And I've already updated it actually. So I just want to show you, whoops. And you can see here that the feature.enabled is on, and producer.bootstrap.servers points to my connector, which I've installed the local Kafka broker on, and port 9092, the default Kafka port. And the topic here is metric-export. This is the topic to which the metrics will be published. So this is just an important part of establishing the connection from NetOps to the Kafka broker. Okay, back on the connector box, we can check on the status of the connector by running service ca perf center underscore oi status. And this looks good. Up top, we see the OI connector agent is running, and beneath that, we can see the OI connector core service is also running. Those two services, again, constitute the OI connector, so it looks like we're in good shape there. Okay, so now that we've got the connector installed, NetOps is configured to begin streaming metric data, the connector looks healthy, I want to do one more thing, and that is to verify that we are, in fact, receiving metrics from NetOps by OI. And to do that, what we're going to do is look at the Kafka broker itself and make sure that it's receiving on that Kafka topic. So I'm within the CA directory. When we did the connector installation, we really did two things. We installed the OI connector, and I chose to install a local Kafka broker. So I'm going to cd into my Kafka directory here, and I will go into this Kafka dist subdirectory, and even further into etc, into bin, and I'm going to run this command here, Kafka console consumer, And what this will do is we'll look at my Kafka Broker and specifically this topic metric export, which is the topic to which metrics are being streamed and subscribed to by the OI connector. And what I expect to see is some metric data flowing. I'll click enter and wow, okay, yep, a lot of metric data coming across from NetOps being received by our Kafka broker on that topic. And I'd just like to show within DX NetOps, if we go into administration and we go to data sources, system status, here we can check on the status of our OI connector. If you scroll down here, we can see that the connector is up, the health is normal, it looks good, and it was last polled a minute ago. The connector will poll NetOps every minute. So just one place to go and check within NetOps on the status and health of your OI connector. So now that everything is installed, configured, data is flowing, we can see what it looks like within OI itself. So what we'll do is let's create a service and let's use some of the network entities that we're retrieving from NetOps portal to build that service. And I will select network as my monitoring domain and PM group as my base attribute. And here you can see all of the PM groups that have been made available to me via the connector. Let's pick one here. We'll pick core routers, and I'll add this to a service. Let's just call it core routers. And click add elements, and we'll click save. Okay, so now the service is being created. Let me refresh. Okay, and there is the core router service that we just created. Let's click on it. And let's take a look at it from the monitored inventory perspective. From this view, we can see that we have our R2 and R3 routers within the service. Let's do a quick jump then into performance analytics to see how this router is performing. As an aside, this monitored inventory view is a great launch point, not only to see the entities that constitute your service, but to jump into performance analytics, alarm analytics, capacity analytics. So let's take a look at performance on that R2. Okay, so here I have all my metrics that have been sent over from NetOps. I'm going to add, take a look at CPU utilization. Let's check reachability, response time, overall availability. We'll add that in here as well. And this looks good. So we were able to create a service, add the NetOps entity, view the performance data that NetOps has shared with OI, and this really concludes the video. I hope it was helpful in reviewing the OI connector, the architecture, the installation, configuration, and how it's represented within OI. Thanks for listening, and take care.